Assalamualaikum friends. I hope so that you all will be fine. Friends, in this video, I am going to discuss about the second part of my previous video. In my previous video, I have discussed about the introduction of H.M.P shunt pathway and steps. Okay, if you are new, then kindly watch that previous video and come on this video. And in this video, I am going to discuss about the importance of H.M.P shunt pathway. So let's start our lecture. This H.M.P shunt pathway, it gives two important products. Two important products, and that are NADPH, okay, NADPH and pentose sugar. Pentose means 5 carbon atom containing sugar. This pentose sugar, it is very important in the synthesis of nucleotides, and it means it is very important in the synthesis of DNA and RNA, deoxyribonucleic acid and ribonucleic acid. Now coming toward the uses of NADPH. The uses of NADPH. Okay, this NADPH, the first use of NADPH, it is very important in the synthesis of it is very important in the synthesis of fatty acid, okay, steroid hormone and cholesterol. They all are lipid. Friends, I have already uploaded a lecture about the fatty acid, steroid hormone synthesis and cholesterol synthesis. You can check the playlist on my channel, and the name of playlist is lipid metabolism. Okay, so this NADPH, it is very important in the synthesis of fatty acid, steroid hormone. Steroid hormones includes cortisol, aldosterone and sex steroid, and that are estrogen, progesterone and testosterone, and last one is cholesterol. Okay, the second use of NADPH is it is very important in free radical scavenging reaction, and for this action it requires superoxide dismutase, peroxidase and glutathione reductase. Okay, it also acts as antioxidant. Okay, and it is required for the NADPH, it is required for the bactericidal action of macrophage. This is the second use of NADPH. It is required for the free radical scavenging reaction. For this action, it requires superoxide, superoxidase, superoxide dismutase, peroxidase, and glutathione reductase. It also acts as antioxidant, and it is required for the bactericidal action of macrophage. Now coming toward the third use of NADPH. This NADPH, it is very important in maintaining RBC's membrane integrity. It is very important in the maintaining maintaining RBC's membrane integrity. Okay, this is very important. Okay, in absence of RBCs, in absence of NADPH, it leads to hemolytic jaundice. Hemolytic jaundice. Okay, because NADPH it is very important in the production of reduced glutathione. It is very important in the production of reduced glutathione with the help of an enzyme that is glutathione reductase. Okay, so this is the third use, that it is very important in maintaining RBC's membrane integrity. In absence of NADPH, it leads to the hemolytic jaundice, and because NADPH it is very important in the production of reduced glutathione, and it is very important in maintaining the membrane of RBCs. Okay, in absence, how this hemolytic jaundice occurs? In absence, because uh, in our body there is continuous production of free radicals that leads to the this is the membrane of RBCs, and there is a hemoglobin. In absence of because free radicals in our body, there is continuous production of free radicals, and the free radicals they damage the membrane of RBCs. So it leads to release of hemoglobin, which is composed of heme and globin, and the degradation of heme, the breakdown of heme leads to the production of bilirubin, and bilirubin it leads to the disorder that is hemolytic jaundice. Okay, so this is the third point. It is responsible for the maintaining the membrane of RBC's integrity, and in the absence of NADPH, it is responsible for hemolytic jaundice, and NADPH it is responsible for maintaining for the production of reduced glutathione. And this NADPH it keeps iron in reduced form, mean in ferrous state, because iron having two forms, ferrous state and ferric state, and NADPH keeps iron in the reduced form, that is ferrous state, that is Fe2 plus. This is the reduced form of iron. Okay. So this is the third point. Now coming toward the fourth point, fourth uses of the NADPH. The fourth point is it is very important for maintaining the transparency of Lenz. Okay. And the last fifth point is it is very important for the detoxification. It is also required for detoxification, and for this detoxification process it requires cytochrome P450. So these all are the uses of NADPH. Okay, now coming toward the clinical significance of H.M.P shunt pathway. Okay, clinical significance of H.M.P shunt pathway. The first one is glucose 6 phosphate dehydrogenase deficiency. Friends, it is asymptomatic. Okay, but when oxidant drugs are given, when oxidant drugs are given like primacoin and sulfur drugs or some antibiotics like acetanilide. Okay, when oxidant drugs are given or antibiotics, they lead to they lead to increase in the production of free radicals and decrease in production of NADPH. Okay, they all lead to the hemolytic jaundice because they damage the membrane of RBCs and they're responsible for the release of hemoglobin, and the degradation of heme leads to the production of bilirubin, and it is very important for the hemolytic jaundice. Okay, so they also lead to the deficiency of glucose 6-phosphate dehydrogenase enzyme, and it is a regulatory enzyme in H.M.P shunt pathway. I am repeating, when oxidant drugs such as primacoin and sulfur drugs and antibiotics they are given, then they lead to increased production of free radicals and decreased production of NADPH, and they lead to the deficiency of this enzyme, and they are responsible for the damaging of RBC's membrane and responsible for the release of hemoglobin, and the degradation of heme leads to the production of bilirubin in blood, and they are responsible for the hemolytic jaundice. Okay. Now, second clinical significance is the second one is the second one is Wernicke's Korsakoff syndrome. Wernicke's Korsakoff syndrome. It this this disorder, syndrome in the collection of disorder. It mainly occurs in consumption of chronic alcohol. In chronic alcoholic consumption that lead to the decrease in absorption of thiamine, and leads to the inhibition of the conversion of thiamine to thiamine pyrophosphate. There is the inhibition of, this is the active form of this thiamine pyrophosphate. It is active form of the, this thiamine. Okay, this thiamine pyrophosphate, it is active form of thiamine. Sorry, mi. Okay. So in case of chronic alcoholic consumption, it leads to decrease in absorption of thiamine, and thiamine, it does not convert into the thiamine pyrophosphate, that is the active form of the thiamine. Okay, and that leads to the disorder that is Wernicke's Korsakoff syndrome. There are some symptoms that are global genes, that is global confusion, ophthalmoplegia, ataxia, memory loss, and psychosis. These are the symptoms of this disorder, Wernicke's Korsakoff syndrome, Goa MP, global confusion, ophthalmoplegia, ataxia, memory loss, and psychosis. Because this thiamine pyrophosphate is very important for the activation of this transketolase enzyme. This enzyme requires this thiamine pyrophosphate for its action, and in the deficiency of absorption of thiamine, it leads to the inactivity of transketolase enzyme. Okay, and they also affect the pyruvate dehydrogenase complex reaction. Okay, so this is the second clinical significance, that is Wernicke's Korsakoff syndrome. It mainly occurs in chronic alcoholic consumption that lead to the deficiency decrease in absorption of thymine and deficiency, and leads to the inhibition of and leads to the inhibit in the conversion of thymine to thymine pyrophosphate, because thymine pyrophosphate is active form of the thymine. And this thymine pyrophosphate is very important for the transketolase enzyme activity. I have already discussed in the first part of the video. This enzyme requires this thymine pyrophosphate, but in the deficiency, it leads to the this disorder, that is Wernicke's Korsakoff syndrome, and the other symptoms of this syndrome. And this way, it mainly affect the transcriptase activity of this H.M.P shunt pathway, and mainly affect the pyruvate dehydrogenase complex reaction. Okay, so keep watching and thank you.